I'm going to start tutorial 2. This tutorial covers a node and mesh schemes, which are important to solve uh, some circuits. Question 1 is very important question because for solving this question, we can understand when we should consider supernode and when we don't need to consider supernode. In this question, we want to find out V1 and V2 with using node scheme in two parts, part A and part B. The circuit for part A is like this. We have two resistors here, one resistor here, and also we have two current source, 4 amps here and 2 amps here. Here we have ground and V1 is here and V2 is here. In part B, the circuit is approximately similar to part A, but only we want to add a voltage source like this. This is 10 volts and we have a resistor here and also here we have 4 amps and 2 amps. The V1 is voltage here and V2 voltage here. Important concept, if we don't have any voltage source in a circuit like part A and we want to solve the circuit by node scheme, we don't need to consider supernode. For part A, we have two unknowns, V1 and V2. If we can find out two equations, equation 1 and equation 2, immediately after simplifying, we can find out V1 and V2. Equation 1 is obtained by applying node scheme in node 1. And equation 2 is obtained by applying node scheme in node 2. In node 1, we have this current, and this current, and also we have 2 amps. That's why equation for node 1 is like this. V1 divided 1 over 6 plus V2 divided 1 over 5 plus V1 minus V2 divided 1 over 3 plus 2 amps is equal to 0. Important concept, if the direction of 2 amps change to this direction, we should put here minus 2 amps. Right now for this direction, here we have 2 amps. Equation 2 is obtained for applying node scheme in node 2. For equation 2, we have this current V2 minus V1 divided 1 over 3 minus 2 minus 4 is equal to 0. To summarize, we have two equations and two unknowns. After simplifying, we can find out V1 and V2. V1 is equal to 0.36 volts and V2 is equal to 0.9 volts. This is final answers for part A. For part B, important concept, because we have voltage source here, we should consider supernode like this. And for this reason, we should find out, we should define Vx here. And important things, first of all, we should determine equation for supernode. For this reason, V1 minus Vx is equal to 10 and Vx is equal to V1 minus 10. This is equation for supernode. To clarify, again in part B, we have two unknowns because Vx is not unknown. And also for this equation, Vx is determined in terms of V1. That's why again we have two unknowns, and if we can find out two equations, equation 1 and equation 2, and after simplifying we can find out V1 and V2. Again, for part B, because we have voltage source here, we should consider supernode. Equation 1 and equation 2 are obtained by applying node scheme in node 1 and node 2. For equation 1, we have V1 over 1 over 6 plus Vx over 1 over 5 plus Vx minus V2 over 1 over 3 plus 2 is equal to 0. For equation 2, we have minus 2 minus 6 and plus V2 minus Vx over 1 over 3 is equal to 0. And also we have equation for supernode. We have Vx is equal to V1 minus 10. If we want to put Vx here instead of Vx here and Vx here and Vx here, again we have two equations and two unknowns like this. Equation 1 and 2 should be simplified like this. 6 V1 plus 5 V1 minus 10 plus 3 V1 minus 10 minus V2 plus 2 is equal to 0. And equation 2 should be simplified. Minus 2 minus 6 plus 3 V2 minus V1 minus 10 is equal to 0. And final answers for V1 and V2 are here. V1 is equal to 4.6 volts and V2 is equal to minus 3.09 volts. This is final answers for V1 and V2 in part B. Once again, in part A, we don't need to consider supernode because we don't have any voltage source. In part B, we should consider supernode in order to. Supernode is important concept in this course. That's why, again, question 2 investigates supernode. In this question, again, we want to find out V1 and V2 by node method for part A and part B. The circuit for part A is like this: 16 ohms here and 16 ohms here and 2 ohms here and 4 ohms here and 3 amps here and reference node here. And also V1 is here and V2 is here. For part B, we have same scenario, only with adding a voltage source. The circuit for part B, again, here we have 16 ohms, 2 ohms. Only here we are adding 2 volt, and again here we have 4 ohms, and here we have 3 amps, and here we have reference no, and V1 is here and V2 is here. Again, for part A, we don't need to consider supernode. But in part B, we should use a supernode in order to solve question in part B. Let us start to solve part A. Okay, question in part A should be solved easy only by divided current law, which we mentioned before in tutorial 1. Please solve question only by divided current source. It's easy, but now we want to solve question by node procedure. Again, to clarify, we have two unknowns here, V1 and V2, and for two unknowns we need two equations. Equation 1 is obtained in the node 1, and equation 2 is obtained in node 2. For node 1, it's easy. We have V1 over 16, again plus V1 over 16, because here we have ground, and voltage for ground should be 0. And for this current, that's why here we have current and this current. And for this current, we have V1 minus V2 over 2 equal to 0. We don't have any constant value because we don't have any current source which connected to node 1. For node 2, we have this current and this current and this current. Minus 3 for this current plus V2 over 4 for this current, and for this current plus V2 minus V1 over 2 is equal to 0. We have two equations and two unknowns. That's why first equation and second equation. After simplifying, which you know how we can simplify two equations and or three equations, after simplifying, we can find out V1 and V2. V1 is equal to 8.57 and V2 is equal to 6.85. This is final answer for part B. And in order to promote your skills for midterm, it's good idea to solve this question part A for only divided current and equivalent resistance and KCL or KV. Now I'm gonna start to solve part B. In part B, we have uh, a voltage here, this voltage. For this voltage, we should consider supernode. In order to find out equation for supernode, we should define here Vx. And equation for supernode uh, is like this. Vx minus V2 is equal to 2. That's why Vx is equal to 2 plus V2. This is equation for supernode, which we need in applying for node 1 and node 2. Again, we have two unknowns, V1 and V2 are unknowns. And for finding V1 and V2, we need two equations which are obtained in node 1 and node 2. Okay, equation in node 1. We have ground here. That's why this current, and this current. V1 over 16 plus V1 over 16 plus V1 minus Vx. Instead of Vx, we have 2 plus V2. V1 minus 2 plus V2 over 2 is equal to 0. This is first equation. Once again, this current should be V1 over 16. This current should be V1 over 16. This current should be V1 minus Vx. Instead of Vx, we can use 2 plus V2. V1 minus 2 plus V2 over 2 is equal to 0. Equation for node 2, minus 3 for this current, plus V2 over 4 for this current, plus this current. This current should be Vx minus V1. Instead of Vx, we can put 2 plus V2 minus V1 over 2 is equal to 0. Again, for node 2, we have this current, and this current. Again, we have two equations and two unknowns. And immediately after simplifying, we can find out V1 is equal to 4.6 and V2 is equal to minus 30.1. Okay, question 3 describes about mesh scheme. Question 3. In question 3, we want to find out V1 by using mesh method. Circuit for question 3 is like this. We have 4 volts here and 4 ohms here and 2 ohms here and 1 ohms here and 8 volts here and 6 volts here and 5 ohms here and 10 ohms here. Important key for this question is we need to define super mesh or not. The answer is easy. Because we don't have any current source in this circuit, therefore we don't need to consider super mesh. Once again, if we have current source in one circuit and we want to solve that circuit by mesh scheme, we should consider supernode. If we don't have any current source in the circuit and we want to solve the circuit by using mesh scheme, we don't need to consider super mesh. Okay, V1 in this circuit is defined voltage here. V1 is defined voltage here. Okay, another important key for this circuit is to investigate how many unknowns we have. For this circuit, if we want to defining this mesh for I1 and this mesh for I2 and this mesh for I3, that's why only we have 3 unknowns, I1, I2 and I3. We have 3 unknowns and therefore we need 3 equations to find out 3 unknowns. That's why we need 3 equations. How we can find 3 equations? By applying mesh method in each loop. Loop 1, loop 2, and loop 3. Each loop provides 1 equation, and total we have 3 equations. For loop 1, be careful, for 4 volts we should put minus. For 8 volts we should put positive. We are applying a mesh in the loop 1. And for this 4 ohms, only we have I1 current, 4 times I1, plus for this 2, be careful, for this 2, we have current I1 and current I3. That's why the voltage for 2 ohm should be 2 times I1 minus I3. And for this 1 ohm, we have current I1 and I2. That's why the voltage should be 1 times I1 minus I2 is equal to 0. This is equation 1. Once again, we have minus 4 here, minus 4 here, plus 8 here, 4 I1, 2 I1 minus I3, and 1 I1 minus I2. Okay, equation 2 uh, is obtained by applying mesh scheme in loop 2. In loop 2, we have minus 8 plus 6 minus 8 plus 6 and plus 1. Be careful, for loop 2 we have 1 ohm here. For loop 2 I2 we have I2 here and I1 here. That's why for loop 2 voltage across of 1 ohm should be 1 times I2 minus I1. And for loop 2 voltage across of 5 should be only 5 times I2 is equal to 0. Okay, once again, for loop 2 we have minus 8 plus 6 plus 1 times I2 minus I1 plus I2 is equal to 0. Okay, for loop 3, we have this equation. Minus 6 uh, plus 10 times I3 and plus, be careful, for 2 ohms we have I3 and also we have I1. That's why for 2 ohms we have voltage 2 I3 minus I1 is equal to 0. In order to clarify, we have 3 equations. Equations 1, equation 2, and equation 3. Right now, it's easy to solve 3 equations in terms of 3 unknowns because you know how we can solve 3 equations and 3 unknowns and find out I1 and I2 and I3. That's why we have I1 and I2 and I3. How we can find out V1? V1 is voltage across of 1 ohms. For this positive and this negative, V1 should be 1 times I1 minus I2 because this is I1 and this is I2. For this positive and negative, V1 should be 1 times I1 minus I2. Okay, question 4 again covers important question about mesh and also supports the super mesh. This is question 4. In this question, we want to find out the voltage across of 1 ohm. We want to find out V1 by using mesh method. It means we should apply mesh method in this question And after finding all of the currents for loops, finally we can find out V1. The circuit is like this. The circuit is like this. We have 4 ohms here, and also we have 4 amps here, and 8 ohms here, and 6 ohms here, and 2 ohms here, and we have 30 volts here, 3 ohms here, and 1 ohms here. V1 is defined here. This is V1, and final goal is to find out V5. Okay, in this question, we have current source here. We have current source here. And also, we want to solve question by mesh scheme. That's why we should consider super mesh. Super mesh is like this. This is loop 1, and for super mesh we can consider loop like this for I2. For loop 3 we can consider I3, and for loop 4 we can consider I4. That's why if we don't have 4 amps, we don't need to consider super mesh. But right now we have current source in this circuit, and we want to solve this circuit by mesh scheme. That's why we should consider super mesh. Okay, again, important key for this circuit, we have 4 unknowns, I1, I2, I3, and I4. In order to find out 4 unknowns, we need 4 equations. We need 4 equations which determined by 4 loops. And finally, we can say V1 is equal to 1 times I4. Be careful in terms of in order to find out V1, only we need I4. But by finding for finding I4, we should find out I1 and I2 and I3 and I4. There is no way to immediately find out I4. Okay, now first equation is easy. I1 is equal to minus 4. Why? Because in loop 1, you can see this is loop 1. In loop 1, this loop, in this loop 1, I1 is equal to minus 4. And for loop 2, we have voltage here. Voltage here is equal to 4 times current. Current is I1 plus I2. That's why we have 4 times I1 plus I2 plus this voltage. This voltage again is 8 times only I2 because we don't have any I1 here. And this voltage is 6 times I2 minus I4 plus this voltage. This voltage should be 2 times I1 plus I2 minus I3 is equal to 0. Again, it's important to investigate. For 2 ohms, we have 3 currents. If we have 2 ohms here, we have I1 and I2 in the same direction and I3 in this direction. That's why the current for 2 ohms should be I1 plus I2 minus I3, and this is second equation. Equation 3 should be like this. And again, equation 3 is easy. Minus 30 plus 2, again important note, 2 I3 minus I1 minus I2 plus 3, this voltage, plus 3 times I3 minus I4. I3 minus I4 is equal to 0. Important note is for this part. And for this part, we have 2 O like this. We have I3 and also I1 plus I2. Because we are traveling in loop 3, we should indicate I3 minus I1 minus I2. Okay, and for equation 4, we can apply mesh in loop 4 and should be 3 times I4 minus I3 plus 6 times I4 minus I2 plus 1 times I4 is equal to 0. And now it's clear. We have I1 here. That's why we have 3 unknowns, I2, I3, and I4. We have one equation here, one equation here, and one equation here. That's why we have 3 equations and 3 unknowns. And after simplifying the 3 equations, we can find out all of the currents. The final answer is I1 is equal to minus 4, I2 is equal to 3.44 amps, I3 is equal to 8.56 amps, and I4 is equal to 4.6 amps. And immediately you can find out V1. V1 is equal to 1 times I4. That's why V1 is equal to 4.6 volts. This is final answer for V1. Okay. Next question. Next question describes about simple circuit which we want to solve by any method. Question 5. In question 5, we want to find out V3 by any method. which means we can use any method like Ohm's law, divided voltage, divided current, and also mesh scheme and node scheme and KVL and KCL. The question is like this. We have 20 volts here and 2 ohms here, 3 ohms here, and 5 ohms here, and 2 amps here. The voltage V3 is here. This is V3, which we want to find out by any method. Okay, important keys. You can solve this question by node scheme and mesh scheme, and also by any method we learned before. Now I want to solve this question by changing this current and this resistors to voltage. Let me explain how we can do. You know, if we have a current like this and we have a resistor which connected to current parallel, we can change the current source to voltage source like this. The voltage here is equal to R times I, and the resistor here is the same, R. Important note, the resistor here is equal to resistor here. Here we have current source, here we have voltage source. And very important note, we have current like this, and here we have current like this. That's why this circuit should be simplified to this circuit. Here we have 20 volts, and here we have 2 ohms. Here we have 3 ohms, and this 5 ohms and 2 amps should be changed to 5 ohms, and 2 times 5 should be 10 volts. 10 volts here. This is circuit after simplifying. Now, if we want to start with defining I here, and after that, by applying a KVL here, we can find out the current, and immediately we can find out V3. How? Here we have positive, negative, positive, negative, and positive, and positive, and negative for 5 ohms. Okay, now we are ready to apply KVL. KVL says minus KVL in the loop A says minus 20 plus 2 times I plus 3 times I plus 5 times I plus 10 is equal to 0. This is equation for KVL. 2 and 3 and 5 connected together series. That's why we have same scenario for current. Immediately we can find out the current is equal to 1 amp, and V3 is equal to 3 times 1 is equal to 3 volts. We solve this circuit only with using one equation. If you want to solve this circuit by node scheme or mesh scheme, you should um, find out more than one equation. In next tutorial, again, we want to explain about important concept in this course and solve important question and investigate how we can solve practical circuit.